The next step in our work with working with patterns involves evaluating expressions for patterns. Now, an expression is like a number sentence. It has a number, it has some kind of calculation, and it has a variable in it. Notice this is an expression 2x plus 10, and it doesn't have an equal sign in it. And you may be asked to evaluate an expression, and you're just trying to figure out how much it's worth. What's the total? What's the value? But when you're doing it connected to a pattern, you have to substitute in values for x because this pattern describes something. It describes what happens in each step of that pattern. And so what we can actually do is substitute the number of the step. We could say, well, what's the 10th number in that pattern? Or what's the 100th number in that pattern? And that helps us figure out what would happen in the future, or to predict prices for something, or to predict what would happen if we had, a giant cookie jar and there were just tons of cookies in there, and no matter how many people sat at that table, we could give them 2 cookies. So writing an expression like 2 times x, 2 times the number of people, helps us predict like what happens when the 10th person comes to that table. And so in this case, we're going to use the expression 2x plus 10, and it will ask us to evaluate an expression for 2x plus 10. That's what the problem would ask for. And so I like to use a chart. I like to set up a table where I put the step, which refers to which number of the pattern it is, like the first number or the second number or the third number. And then the value, which is after we plug the step number into our expression, how much is that expression worth? So for example, I would always start with step 1. Step 1 is usually would be the first number in the pattern. And then I would rewrite that expression with that number in there, 2 times 1 plus 10. So where our x used to be, that's where I'm substituting that number in. So of course I'd have to follow order of operations. I'd have to do the 2 times 1 first. 2 times 1 is 2, plus 10 gives me 12. So the first number in that pattern is actually 12. And then the second step, I would just count in order, 1, 2, 3, 4. So the second step would be 2 times 2 plus 10. And again, I have to follow order of operations. So 2 times 2 would be done first, which is 4. And then 4 plus 10 is 14. Then I would try number 3. 2 times 3. Notice I'm using just the raised dot for the multiplication symbol. We don't want to put an x in there like the multiplication symbol that we're used to, just because we don't want to confuse it with our variable. So 2 times 3 plus 10 gives me 2 times 3 is 6 plus 10 equals 16. Now we might describe this actual sequence here as just adding 2 each time, but we have an interesting point to think about is that we started with at least 10. So every step has to be above 10. I'm going to try this with 4. 2 times 4 plus 10. And of course that's going to give me 18. And we'll try it with 5. 2 times 5 plus 10 gives me 20. So if I'm asked to give like the first 5 numbers in this sequence, I would write it out as 12, 14, 16, 18, and 20.